So in this session, the first concept that we'll talk about is a thread priority. Now, what do you mean by a thread priority? See, in the previous session, when we spoke about multi-threading, we said our system has a processor, right? And say when multiple applications are running, they will come in the form of a queue. So this is a thread, say T1, then there is a thread, say T2, then there is a thread, say T3, and so on, right? And these threads will come in the queue and then they'll get executed on time sharing and time slice basis. But does this mean that every thread gets executed on first come first serve basis? No. See, please understand this. Agreed that it might sound to be fair that every thread which comes in first should be able to get executed first. So we should be able to execute this on first come first serve basis. That is what we are expected to do. But practically it does not happen. Now please understand this. When you talk of a thread, there is something called as the magnitude of a thread, right? Now magnitude of a thread. Now understand, what do you mean by the magnitude of a thread? Now, if you look at this particular screen, so currently I'm running this PowerPoint presentation in my system. So currently, what's happening is in my computer, say this is my processor. Say suppose this is that PowerPoint thread, say PPT thread. I'm calling it as PPT, which is currently getting executed, so that you can see this presentation. Now, I don't know, there might be so many threads in this queue on my computer. On an average, there would be about 1600 threads on your computer, live threads on your computer. So there is this queue working. But now when I go this way, say Control Alt Delete, immediately it gives me the task manager and then I immediately get to see the screen. Now observe what has happened. Task manager is another thread which I've just started. Now this is what I've been talking. See, currently on my computer I have 1708 threads. Again, this number will keep changing over here. I have 110 processes running on an average. So in that particular queue, there are 1700 odd threads that we have. But as soon as I hit Control Alt Del, understand there was a new thread which was created. Now say this was the thread, say X, which was created for Control Alt Del. Now what the system could have done is the system could have just got this thread and added it at the end of this particular queue. But it did not do that. What it did is you saw that everything was halted and straight away this thread was brought in over here. See, please understand, if I hit Control Alt Del, if I use that option, see, nobody uses it for the heck of it. Okay, you're sitting and then you got bored, so you're hitting Control Alt Del. Aisa nahi hota. So over here, when I hit Control Alt Del, what the system understands is that over here, each thread, over here, there is something urgent that needs to be looked at. So what it did is it got that particular thread and it got it ahead of everything else that was executing. So moment I hit Control Alt Del, my task manager will open and everything else that is happening currently will then be stopped. Now, why is this that this thread has come in between? See, this is because the importance of this particular thread, Control Alt Del. Now, this is a combination which say we are using with reference to the operating system, which is generally used for performing certain critical operations. So that is why this thread has been given a priority. Understand, every thread that you run on your computer will have a priority, and when you are inserting a particular thread in the queue, it's not always first come first serve basis. It is always using the option of priority. See, on my computer currently, these are so many different processes, so many threads which are running currently. So each of these threads has their own priority. So that is what we need to understand, right? So this is how these threads are going to work. So many threads are executed. That doesn't mean that your threads will always execute on first come first serve basis. No, it doesn't execute on first come first serve basis. It is executed based on the priority. So these are so many different services which are running on our computer, and this is how the threads are being programmed, right? Okay. Now, so what I understand over here is whenever there is a thread, so there is a priority associated with this. So whenever we work with a thread, it works in a queue, but it is not an ordinary queue. It's a priority queue. So now suppose currently on my computer, there are 3 threads executing, say thread A, thread B, thread C. In Java, the priority for the threads is numbered from 1 to 10. 10 is the highest priority and 1 is the lowest priority. So suppose thread A has priority 8, thread B has priority 5, thread C has priority 4, and so on. Now suppose a new thread comes in like this, right? Suppose thread D. Now thread D, by default, you might feel that I should get this thread D directly at the end of this particular queue. My thread D should go in over here. But no, it does not happen. What the system will do is, because the system is using what is called as a priority queue, it will just check the priority of this thread. What it finds is that the priority of this thread D is less than that of A, but more than that of B and C. So D will get inserted directly over here. So this is a priority queue that is going to be used. So what we can do is, by default, see, whenever I create a thread in Java, by default, the priority is set to 5, right? That's the default priority. But if need be, I can always change this priority. I can always change this priority. So that is what we need to understand over here. So we'll now go to programs where we'll manipulate the priority of the thread, and accordingly we'll try and get the outputs, right? So every thread will have a priority. Now, always remember, whenever we are working with a concept of queue, it is always a priority queue. Okay. Now look at this concept of thread practically. Now this is I'm using a Windows-based system. So on my system, on my Windows-based system, what I've done over here is I have these many processes running. We saw that there are so many threads, about 1700 threads running currently around on my system. Now when I go to detail, see, these are the threads which are running. Now this is what is the queue which we have in Windows, which is getting executed on time sharing and time slice basis. So that is what we have over here. Now if I select any thread randomly, suppose if I select this, right, and if I go, if you see, there is a priority which is set to that particular thread. Now Windows has all these priorities: low, below normal, normal, above normal, high, real time. By default, the priority of the thread set to in Windows is normal. So all these are the threads running. You pick up any thread and you check according to the importance of the application to which it belongs. You have different priorities over here. So over here, Windows is also using a processing queue, but it is also a priority queue. Now Windows has named the priorities in the form of low, below normal, normal, above normal, high, real time, and so on. In Java, it is numbers. So in Java, you will find that they are numbered from 1 till 10. Now, if you see, I've just selected one particular thread which actually belongs to the operating system. So if you see, the priority set to that one is high. So what the system will do is it will never make this thread wait for a lower priority thread. So this is an operating system thread. So that is why the priority is high. If I take up any application, like currently if I have an application running, suppose say I have PowerPoint running on my computer. So if I take its priority, it's a normal application. So the priority is normal. So this is how the way Windows sets the priority to normal. Similarly, in Java, priorities are numbered from 1 till 10. The default priority of any thread that is created in Java is 5. But if need be, we can always change this priority. Okay, observe this. Look at this program. I'll demonstrate this with the help of the program. Now this program is exactly the same as the one that we've used in the previous session. So over here, I've created this class T1. How do we create a thread? 3 steps. Derive a class from class thread. Step 2, write a run method inside this class. Step 3, create an object of this particular class. This object that you create is a thread. So over here, I've created this class T1 extends thread. I've written a run method which is executing this for loop, which is printing T1 say 5 times. But between this for loop and this system, I've written sleep as 5000. You know this, that I've just slowed down this program so that the output is visible to you. Multi-threading is visible to you. Apart from slowing down the program, there is no other reason. There is no other reason why I have added this try, catch, and sleep methods. Similarly, I've created another class T2. I'm going to create multiple threads. That is why I've created multiple classes, right? So that you can understand things better. So I've created this class T2. There is a run method inside this, which will again print T2 say 5 times. And then you have sleep method over here. I've created one more thread, say class T3 extends thread. So over here, I have 3 thread classes, T1, T2, T3. Now what I'm going to do is I'm going to create an object over here. So what I do is I'm creating 3 objects. T1x is equal to new T1. X is an object of class T1. So this is a thread of class T1. Y is a thread of class T2. Z is a thread of class T3. Over here, when I create these threads, default priority set is 5. But now suppose if I execute this program, what I'm doing is, before I start this, see, you can say over here, the threads are in a newborn state. I need to get them in an active state. Only then the threads are going to start running. Now that will happen only after I use the start method, right? But before that, what I do is x.set priority to. So this thread belonging to T1, I've set the priority to 2. So I've reduced the priority. Y.set priority is 9 and Z.set priority is 6. So you will see that the thread belonging to this class T1 has the least priority, the thread belonging to class T2 has the maximum priority, and the thread belonging to class T3 has intermediate priority. Now I'll start these threads x.start, y.start and z.start. Now when this program runs, you will see, even though I have written the statements in this sequence, because y has the highest priority and y is a thread belonging to class T2. So what I'll do is, I'll first see T2 being printed because that thread will get executed first. So I'll see T2 first, T3, T1, T2, T3, T1. So whenever I'm required to determine, or whenever I'm required to control the sequence in which the threads are to be executed, we'll always use it. We will always do that using this priority. Is this understood, please? So this is how we are going to work with these threads. So you can actually set the priority and you can control the sequence of execution of the statements in the program. So that is what is thread priority. Very popular in examinations. If they want to ask you some programs on threads or multi-threading, they generally ask from thread priority. Thread synchronization. Now this is the last of the concepts that we are required to study in this particular chapter. We'll first try and understand why is synchronization needed, what is synchronization, and how does Java go about synchronizing threads. See, a lot of times when students see these programs involving synchronization, they don't understand the programs. They'll generally complain, okay, the synchronization is something which I don't understand. समझ में नहीं आता, ऐसा बोलते हैं. See, it is not synchronization where the problem is. No, not at all. Please understand, there is a problem in any system which uses multi-threading. Any system will face a problem of race condition. And the solution to this problem of race condition is synchronization. So a lot of times students don't understand the idea of race condition only. That is why they don't understand synchronization. So what I'm going to do is, in my initial discussion, I'm not even bothered about synchronization. I don't care what synchronization is, just forget it. Let us first try and understand what exactly is this race condition. Moment you understand that, the concept of synchronization is very, very, very obvious. So let us first focus and try and understand the concept of race condition. See, observe this. See, what happens is, suppose I have, say, a song called, say, S1 on my computer. What I've done is, I'm playing this particular song, say, using Windows Media Player, right? So this song is playing. So currently I'm listening to this song. Now, as this song plays, what I do is, I just minimize the Windows Media Player and I go to this particular song, right click and delete. So this file is currently playing, this song is being played. I just go to that particular song, right click and delete. Try and recollect what will happen in such a scenario. Now, as this song keeps playing over here, suppose if I try to delete this particular song, no, it will not let me delete it. It will say that this file is currently being used by some other application. It will not be allowed to delete this particular file. Imagine if Windows Media Player was playing this particular song, and if someone else could just come and delete this particular song and leave, and if say this song gets deleted, then won't this application become unstable? So till you have another application using the data, the system will never ever delete or will not let you modify that particular file. So how do I define this particular scenario? So over here, I have this song S. There is a thread which belongs to, say, Windows Media Player, which is trying to access this particular data. Simultaneously, at that very moment, there is another thread, which is say T2, which is also trying to access this particular data. When two different threads, they try to access the same data at the same time, this is called as race condition. See, in this environment where you have multiple threads, suppose I have multiple threads, say T1 and T2. Suppose T1 is working on data X and T2 is working on data Y. There is absolutely no issue. There are two independent threads working on two different data. But when you have multiple threads, say two threads trying to access the same data at the same time, this is called as race condition. And if this is not handled properly, the entire data might get corrupted. So in multi-threading, in multi-threaded environment, this threat is always there. So that is why you need to implement the solution. You can think for yourself. Windows Media Player is playing a song, and simultaneously some other thread, say X, comes in, deletes that song and leaves. In that case, Windows Media Player will not have data to play. So that is where the problem begins, right? Now, what I'm going to do is I'm going to discuss the first program with you. In this program, on purpose, I'm going to generate this race condition. Then you will see what is the problem which is happening with the race condition. And then I'll give you the second program, which will be the solution to this problem of race condition. So the first program that I'm going to discuss now is not involving synchronization. The first program would be just generating say, this race condition, and then we'll try and solve this problem. This term race condition you will not find in Java. This is a term which we use in operating systems, right? Okay, now just look at this program very carefully. Now over here, just look at this. I've created this class called sync1, right? Now when I create this class called sync1, important, I've not derived it from class thread. I've not written class sync1 extends thread. No, this is a normal class, say sync1, right? Now over here, I've declared a variable A, which I've initialized using a constructor. I've initialized it to this value 0. Then what I've done is I've written this method called data inside this class called sync1. Now what this data method is going to do is, over here, I've written a for loop which will repeat twice and which will increment the value of A twice. So precisely whenever I come to this data method, what this data method would do is, this data method would increment the value of A twice, and later on it will just go and display the value of A. So if you ask me, what is this data method doing? When invoked, this data method will increment the value of A two times and it will then display the value of A. But the important part over here is, you see this for loop which is incrementing A twice, and you have the system.out.println which is displaying this value of A. Between these two, I have put this thread.sleep 2000. So I'm blocking this thread for 2 seconds. This is 2000 milliseconds. So this is 2 seconds, right? And because this thread method can generate an exception, we've used try catch. So precisely what is happening is, this for loop will execute. It will increment the thread twice. Then my function will stop for 2 seconds, and then it will try and display the value of A. So what you need to keep in mind over here is, whenever I execute this data method, after it has incremented the values of A, there would be a delay of 2 seconds before the value of A gets printed. The reason why I'm emphasizing so much on these 2 seconds is because everything that has to go wrong in this program will go wrong because of these 2 seconds. So data method is supposed to increment the value of A twice and display the value of A. But rather than keeping it normally, what have I done? Over here, I've just put asleep. So what is happening is, it will increment A twice, wait for 2 seconds, and then go and display the value of A. So that is what is happening. So this is the end of class sync1. I repeat, sync1 is a normal class. It is not a thread class. Okay, so this was my class sync1. I hope this is understood. Now going further, I'm creating another class. Class sync2 extends thread. So sync2 is a thread class. So what this means is, whenever I create an object of class thread, object of class sync2, it will be a thread by default. Now inside this particular class, I've written a constructor, right? Don't bother about this as of now, right? I've written a constructor over here, which is going to initialize the components of class sync2. And then you have this run method. Now from inside this run method, I'm invoking this data method. So what is going to happen is whenever I create a thread which belongs to class sync2, it will call this run method, and because of this it will call this data method which we've written over here. So currently just understand this much, that we have this class sync1 which is a normal class which has variable a and it has a method called data. Then I have this thread class called sync2. So whenever I create an object of class sync2, it is going to be a thread. There is a constructor inside it. The role of that constructor I'm still to discuss. And then there is a run method which will invoke the data method that we just saw. So what this tells me is any object of class sync2, whenever I create, one, it will be a thread, and second, on execution, it will always try and execute this data method because it will call run, and run will then invoke data method from over here. So this is what is the structure of the program. Now let us look at main. Now there are some 4 or 5 lines in main. Don't bother. We will look at only one statement at a time. Just concentrate properly. Understand, observe what's happening over here. Now when I start this class execute, I'll go over here. Sync C1 S1, sorry, sync1 S1 is equal to new sync1. Over here, I'm creating an object of class sync1. Now sync1 is this particular class. So what does this look like? I've created S1 as an object of class sync1. So S1 is an object of class sync1 which contains this variable a, which is initialized to 0 because of the constructor. Now over here, I've just gone with an assumption that I've created this object S1. The address of this particular object is 100. Everything that occupies memory literally will have the address as 100, right? So this is what we've got. Okay. Now, so first statement, I hope the first statement is understood. Sync1 was an ordinary class. So S1 is an ordinary object. Now, see, sync2 is my thread class. Now observe what I'm doing. I write sync2m is equal to new sync2. Don't bother about this as of now. Sync2m is equal to new sync2. So m is an object of class sync2. Sync2 is a thread class, right? So any object of class sync2 would be a thread by default, and it is storing sync1p. Now what is this? See, this is like a reference to some data in class sync1. This is kind of pointer. I should not use the word pointer in Java, but this is kind of pointer p, which currently contains nothing. So over here, I've created this object m, which is a thread of class sync2, right? Which has this p. But understand this, whenever I create an object, that is when the constructor gets executed. Now, if I'm telling you that this sync2 is an object, sync2 is a constructor, then this will get created whenever I create an object of this class sync2. But understand, this is a parameterized constructor. For this constructor to work, I need to pass a value of the class type sync1. Or in other words, you can say, whenever I create an object of class sync2, for this constructor, I need to pass another object of class sync1. So what have we done over here? Look at this very carefully. So over here, when I'm creating this object, say m, right, it has created this, but what I'm doing is, because that constructor needs an object of class sync1 to be passed, I've passed s1 from over here. What is s1? S1 is the object that I have created. So basically, this object s1 is now passed as an argument to that constructor. Now, when you're passing an object, what exactly is passed? See, whenever you're passing an object, the address of that particular object is passed over here. So exactly what's happening out here, observe, this is what my class sync2 looks like. When I write sync2m is equal to new sync2, this has created the object. This s1 from over here gets copied to this x. So s1 gets copied to this s, and s1 gets copied to p. But when I say s1, what do you mean when you're passing an object? See, when you say you're passing an object, you're actually passing the address of that particular object. So over here, when I've passed s1, it is not say object s1 per se that is passed. You have passed the address. So this address of object s1 is say 100. That is passed to x, which then goes to p. Which is this p? Now this statement is getting executed for m. So the reference, the pointer inside m, which is p, gets this value x. So this value gets copied over here. So p now becomes a pointer to this object. I repeat this again. I first created an object S1 of class sync1, which is a normal object. Then I'm going to create an object M of class sync2. M is going to be a thread which currently contains P, which is a reference which does not contain anything as of now. But inside this constructor of sync2, I need an object of class sync1. So that is why while creating this object M, I'm passing S1, which is an object of class S1. Sorry, which is an object of class sync1. So when I pass this S1, when this object is passed over here, it is actually the address of that object that gets passed, which gets copied into P. So this is how P, which is inside M, which is a thread, now has access to this object S1. So basically what has happened is I have created an object S1 and I've created a thread M, which has the address of this object S1, and it is trying to access the data inside S1. So what is M doing? M is a thread which has the address of object S1 and it is trying to access the data, which is A, inside S1. That is what has happened so far. I hope this is clear. Similarly, I create another object, sync2n. I'm creating another thread n. Now for this thread also, I'm passing S1. So I'm passing the address of S1. So this value 100 will now get copied to P inside n as well. So n is now also a thread which is trying to access, say, S1. So this is what has happened so far. So if you look at my 3 lines of code over here, look at this very carefully. What have I done? These 3 lines that you see, first line is actually creating this object S1, and the next 2 lines are creating threads M and N, which will both be pointing to S1, and both the threads M and N are trying to access S1 at the same time. I'll now get both these threads started. So what has happened over here? I now have 2 threads M and N who are trying to access the same data at the same time. This is where I can say I've created a race condition. So over here, I have a thread which is trying to, I have multiple threads trying to access the same data at the same time. A race condition has been generated. Now we'll go ahead with the execution of the program and we'll try and understand what will go wrong if at all a scenario like this gets created. So let's try and see what happens because of this. So over here, I have this object S, which now has 2 pointers, say M and N, 2 threads, which are trying to access the data. Now, what have I done? After this was done, I've started both the threads. So M and N, both are threads. I've got them in an active state. So both the threads will start running parallel. Now understand this, both these threads, they belong to class sync2. Now look at my code in sync2. See, my code for sync2 was this. So over here, both these threads, when they run parallel with their name, say as M and N, both will call this run method. So both threads M and N will actually call the same data method, right? So that is what is going to happen. So let us now concentrate on the execution part. So we've got the first 3 lines of my main method was these, creating an object and creating 2 threads. Now observe, I've got the thread started. What's happening in execution? Try and recollect from the previous session, we spoke about time sharing and time slice. Now over here, first say thread M gets access to this processor. So what this thread M will do is, thread M will start executing. This thread M will call the data method that we have over there. Now what that thread will do is, now M has access to this particular data. So M is accessing this. This variable A was 0. Then what this data method did is, it came over here, it incremented A twice. So it became from 0 to 1 and 1 to 2. Now this data method has actually incremented A twice. It now wants to print A, but between these two, we've put a sleep method. Right. Now what happens is, this thread M now has access to this object S1. So over here, when it went to this object S1, it incremented the value of A twice. But what happens is, before it could display the value of A, it goes in the sleep mode. Now when this thread M goes to the sleep mode, in the meantime, the time slice of M expires. When the time slice of M will expire, M will have to give up the resources, and these resources will then be allocated to N. In other words, before M could complete its work of displaying the data, we have another thread coming in. Now N comes in, Now n will come to this particular data, because n is again calling this data method. Again in this data method, I'm planning to increment a twice. So n comes in over here. It finds the value of a as 2. So 2 to 3, 3 to 4. It changes the value of a to 4. Now even n is supposed to display a, but even in case of n, before I display, there is a sleep module, sleep method. So n also, it has incremented the value of a. A has now become 4 from 2. But before n could display, the time slice of n will also expire. So when the time slice of n expires, in that case, it will have to leave the resource and give it back to m. Now, when m comes back from the sleep mode, the value that it sees is 4. Please understand, the value that m had got was 2, but before m could display that particular value, n came in and changed the value, and m doesn't even know that from its last increment till now, when it is displaying the value has changed. So m will come, display the value of a as 4, go back, m has completed its work, then n comes in, n will also display the value of 4. So my program will generate the output as 4 and 4 rather than 2 and 4. My answer should have been 2 for m and 4 for n, but my answer is 4 and 4. So this is what is the problem that happens with synchronization. Two threads have tried to access the same data at the same time. There was no communication between them, and that is why the data can get corrupted. Now imagine, on our computers, there are hundreds of threads which are running parallel. There might be so many threads who might be trying to access the same data, at this. They might try to access the same data at the same time. So that is where we need to be extremely careful. So thread synchronization is extremely needed, because if the race condition appears, my data can get corrupted. So to prevent the data from getting corrupted, Java implemented the concept of thread synchronization using the keyword called synchronized. So again, just one word I'm going to add to that program, and everything will be taken care of. Now that is actually the power, or you can say the strength of Java. I'll just add one word to the program and everything would be fine. Now what is the solution to this problem? See, currently what is happening is I have this value a, which currently is 0. There is m trying to access this. There is n trying to access this. Both are trying to access simultaneously, and that is where things get messed up. The solution to this is mutual exclusion. Now, what do you mean by mutual exclusion? What this means is, suppose I have this data A, it is currently being used by, say, thread M. Unless and until M releases this particular data, N will not be allowed to access this data. When multiple threads won't be allowed to access the same data at the same time, then the whole problem is going to be solved. So what is the solution to this problem of the problem of race condition is mutual exclusion, and I'm going to implement it in Java using the keyword synchronize. Now understand, my entire program remains exactly the same. I've made just one change. See, all that issue is happening inside this method called data. Just before this method data, I've added this word synchronize. So compared to the previous program, there's just change in one word. I've added this word synchronize before this particular function called data, and my output will be this. Now observe what happens over here. Now I'll again go back to this slide. I think it's better that we understand it here. See what happens in this case is, to start with, in this case, what happens is, first M comes to access this data. Now M, because of that word synchronize, it will be checked whether this data is being used by someone else. M finds that no one else is using this data. So what it does is, it goes and changes the value of A to 2. And then M goes into sleep mode. Now when M goes into sleep mode, so the time slice expires, and now N comes in the meantime. But now because of the keyword synchronize, N will also check, is the data being used? It finds that yes, this data is being used by someone else. It doesn't know that it is M. It is just saying that the data is being used for someone else. So N will have to wait. N will not be allotted that particular data. Then what happens is M comes back from its sleep mode. It will go out. It will display the value of 2 and M then completes its work. M is gone. Once M is gone, now N is given access to this. Again, it will be checked. Is this data being used by someone else? No. Now N gets this particular data. Now what N will do is, N will change this data from 2 to 4. Then N will go to sleep mode. Again, till N is in the sleep mode, if someone else is trying to access A, they don't get access to it. N comes back from the sleep mode, it goes, it displays the value of A as 4, and then N completes its working. So that is why I'll now get my output as 2 and 4 instead of 4 and 4. So this is how Java will implement mutual exclusion and solve the problem of race condition using the keyword synchronize. So in a multi-threaded environment, synchronization, thread synchronization is extremely important. So that is what is thread synchronization. That is the concept, and that is also the chapter for us.